Hello everyone, welcome back. This is the part 3 of inverse trigonometric function. In the first part, we discuss about the basics, that is a function, inverse of a function exists if it is 1, 1 and on 2. We explain you that concept. In part 2, we discuss how to find out the principal value, domain and range of inverse trigonometric function. That link is given in the I button, so you can click, you can check those two parts. Now today in this part we are going to discuss the formula and we are going to solve some problems. So first set of formula is sine inverse of minus x, cosec inverse of minus x and tan inverse of minus x. If you remember the part 2 when we are discussing and I am giving you tricks how to remember this formula, in range I form a triplet of these three only: sine inverse, cosec inverse, tan inverse, because what is the range? Closed interval minus pi by 2 to pi by 2, closed interval minus pi by 2 to pi by 2 minus 0, open interval minus pi by 2 to pi by 2. Remember this triplet? Same. In these three cases, formula will be minus sine inverse, minus cosec inverse, minus tan inverse. So if you remember that triplet, you can easily remember these three formula. Okay. These three triplet, sine inverse, cosec inverse, tan inverse. So in these three cases, it will be simply minus sine inverse, minus cosec inverse, minus tan inverse. We again form another three triplet in the same order: cosec inverse, sec inverse and cot inverse. Their range is 0 to pi by 2 closed interval 0 to pi, minus pi by 2, 0 to pi, open interval. In this case, it is pi minus pi minus pi minus. So it is very easy to remember the formula if you make some pattern. So once you make a pattern, you need to just remember the pattern, how you are going to remember those formula. Now see, we form the triplet as sine inverse, cosec inverse and tan inverse. Next is cos inverse, sec inverse, cot inverse, to remember our range. So in this case, sine inverse of minus x, cosec inverse of minus x, tan inverse of minus x is minus sine inverse, minus cosec inverse, minus tan inverse. Here pi minus pi minus pi minus. Sine inverse x plus cos inverse x, cosec inverse x plus sec inverse x, tan inverse x plus cot inverse x. Result is pi by 2. And this part represent the domain. Domain of sine inverse and cos inverse: minus pi by closed interval minus 1 to 1, set of real number, and mod x greater than equal to 1 means x is greater than equal to 1 and x is less than equal to minus 1. So this can also you remember as r minus open interval minus 1 to 1. Clear? So my advice is, sometime we heard lot of sir, we forgot the formula. How to remember the formula? My dear, make some pattern. In every formula, we'll discuss the trigonometric in very soon. So we'll discuss how you are going, what is the trick to remember all those formula. So here I will give you the trick, that range you can form a triplet of these three. So now see, this triplet and they are connected in the same way. Clear? So let us discuss another set of formulas. Moving into the next formulas, tan inverse x plus tan inverse y is equal to tan inverse of 1 plus x plus y by 1 minus xy, where xy is less than 1, and in case of tan inverse x minus tan inverse y, see, numerator sign is negative, denominator sign positive. Now, this is not a new formula. The trick is, if you remember this formula, tan of a plus b, formula is tan a plus tan b, 1 minus tan a tan b. And tan of a minus b formula, tan a minus tan b, 1 plus tan a tan b. So in that way you can remember this formula, tan inverse of x plus tan inverse y, tan inverse x minus tan inverse y, where xy is less than 1 and xy is greater than minus 1. These two are going to use many a time. Now what will happen if xy is greater than 1? This is not there in the CBSE portion. So my advice is we are going to apply this formula because it is not in the scope of the book. So we leave this. In reference book you find this formula. Now moving into this, to tan inverse x there are three formulas. Sin inverse of 2x by 1 plus x square, cos inverse of 1 minus x square by 1 plus x square, and tan inverse is equal to 2x by 1 minus x. Now if you remember this one, you can easily find this two formula, because sine is the ratio of p by h. So in a right angle triangle, p is equal to 2x and h is equal to 1 plus x square. So using the Pythagoras theorem, you can find out the base. So base is equal to square root of h square minus p square. Clear? So if you simplify, so you'll get 1 plus x to the power 4 plus 2x square minus 4x square. So this is equal to 1 plus x square plus 2x square minus 4x square is equal to minus 2x square. So this will be equal to 1 minus x square whole square. So this is equal to 1 minus x square. So cos is the ratio of b by h. So you will get this formula. And tan is the ratio of p by b. So 2x by 1 minus x square. NCERT given very limited formula. So those who are eyeing for competitive examination, go through the NCERT. They have given the very relevant formula. So don't need to go through all the formulas given in the other reference book. Concentrate on this formula given in the NCERT. They are given very relevant formula, very useful formula. Clear? Now we are going to discuss some problem based on inverse trigonometric function. Moving into the problem, let us discuss the first problem. 3 sin inverse x is equal to sin inverse 3x minus 4x cube, where x belongs to minus 1 by 2 to 1 by 2. So this is information about the domain, so no need to worry about. Whenever sum is given, concentrate on the sum. This part is actually given to define the function. So we have to prove these two. So we'll take right hand side, sin inverse 3x minus 4x cube. Now if you remember the formula of sin 3 theta, sin 3 theta is equal to 3 sin theta minus 4 sin cube theta. Now look at the pattern. 3x minus 4x cube, 3 sin theta minus 4 sin cube theta. So you need to recall all those formula we learned in class 11. So that will help you to solve this inverse trigonometric function. So we substitute x is equal to sine theta. Clear? So if you substitute x is equal to sine theta, so it implies theta is equal to sine inverse of x. Theta is equal to sine inverse x. So now we substitute sine inverse. In place of x we substitute sine theta. So 3 sine theta minus 4 sine cube theta. So this is equal to sine inverse. This is the formula of sine 3 theta. So we write sine inverse of sine 3 theta. So sine inverse sine theta is equal to theta. So sine inverse sine 3 theta is equal to 3 theta. And theta is equal to sine inverse x. So we write 3 sine inverse x. And this is equal to left hand side. So, if you are doing the sums like this, you need just go through the formula we learned in class 11. So, it will help you in case of substitution. Moving into the next problem, we have to prove that tan inverse of 2 by 11 plus tan inverse of 7 by 21 is equal to tan inverse of 1 by 2. So, first we'll take left hand side. Now next we are going to apply the formula tan inverse of x plus tan inverse of y is equal to tan inverse of a plus b formula. So x plus y by 1 minus xy. Clear? So if we apply the formula, so tan inverse of, in place of x we need to substitute 2 by 11, in place of y we need to substitute 7 by 24. So we write 2 by 11 plus 7 by 24 by 1 minus 2 by 11 into 7 by 24. Till now, I think we just apply the formula here. Tan inverse. Now, we simplify the numerator and we simplify the denominator. So if you simplify the numerator, so LCM will be 11 into 24. And if you simplify the denominator, 11 into 24, LCM will be 11 into 24. So now, why I am writing denominator part first? Denominator of numerator and denominator of denominator, because I want to show you, don't waste your time by multiplying these two terms, because anyhow these two terms is going to cancel. So leave it like that. So if you simplify 24 into 2, 48 plus 11 into 7, 77. Now if you simplify this, 24 into 11, so 24 into 11, 24, 24, 264, so 264 minus 40. So these two denominator will cancel each other, so it will be tan inverse 48 plus 77. 125 and if you simplify 264 minus 14 is 250. 125 1 ja 125 2 ja. So you will get tan inverse of 1 by 2. Clear? So calculation part you need to be very smart, so that unnecessary part you doesn't need to calculate. If you are seeing that these denominator will cancel each other, no need to simplify. Moving into the next problem, 2 tan inverse 1 by 2 plus tan inverse 1 by 7 is equal to tan inverse 31 by 17. So we'll take the left hand side. So this part, 2 tan inverse of 1 by 2, we are going to apply the formula of 2 tan inverse x. So formula of 2 tan inverse x is equal to tan inverse of 2x by 1 minus x square. Clear? So we write here tan inverse of 2 into x, where x is equal to 1 by 2. If you compare these two formula, 2 tan inverse x, so x is equal to 1 by 2. So tan inverse 2x by 1 minus x square, that is 1 by 2 square, which is equal to 1 by 4, plus tan inverse of 1 by 7. If you forgot this formula, then you can alternatively tan inverse x, you can also use this formula. How you will use this formula? Tan inverse of x plus y by 1 minus xy. Now see, if we write x is equal to y, then tan inverse x plus tan inverse x, which is equal to 2 tan inverse x. 2 tan inverse x can be written as tan inverse x plus tan inverse x. So in this formula, if you replace y is equal to x, then you will get tan inverse x plus x, which is equal to 2x, 1 minus x into x, 1 minus x square. So I told you this formula is very useful. So if you forgot this formula, you can apply this formula by taking y is equal to x. So if you see, continue with our problem. So tan inverse, these two and these two will cancel each other. So numerator it will be 1 by 1 minus 1 by 4. So that is equal to 3 by 4. So 1 by 3 by 4 is equal to 4 by 3. So tan inverse 4 by 3 plus tan inverse of 1 by 7. Now next we are going to use this formula, tan inverse x plus tan inverse y. So this is equal to tan inverse x plus y, 4 by 3 plus 1 by 7 by 1 minus 4 by 3 into 1 by 7. Now we need to simplify this one. So this will be equal to tan inverse, LCM is 21. We are simplifying the numerator part first. So 4 7 ja 28 plus 3, 31. LCM here, denominators, if you simplify the denominator, LCM is 21, 21 minus 4, that is 17. These two, 21 and 21, denominator of numerator and denominator will cancel each other. So this will be equal to tan inverse of 31 by 17 is equal to right hand side. Now let us take this example. Write the following function in simplest form. tan inverse of square root of 1 plus x square minus 1 by x. Here we need to apply substitution. Now, how you select the correct substitution? Look at this term 1 plus x square. If it is 1 plus x square or 1 minus x square, so first preference will be given to the trigonometrical identity. So what are the trigonometrical identities? You know, sin square x, theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to sec square theta, and 1 plus cot square theta is equal to cosec square theta. Now, if you look at this term, square root of 1 plus x square, so in place of x square, we can substitute tan square. That means, if we substitute x is equal to tan theta, you can also go for cot also. Clear? So, but look at the form which will match with the formula. We substitute that trigonometric function in place of our variable. So if x is equal to tan theta, it implies theta is equal to tan inverse of x. Theta is equal to tan inverse of x. So tan inverse, if we substitute x is equal to tan theta, so we will get 1 plus tan square theta minus 1 by tan theta. So 1 plus tan square theta is equal to sec square theta. So this will be equal to tan inverse. So square root of sec square theta means sec theta minus 1 by tan theta. Now we further simplify. Tan inverse sec theta can be written as 1 by cos theta minus 1 by sin theta tan theta. We are writing as sin theta by cos theta. Why I am writing this as sin theta by cos theta? So that this cos theta and cos theta will cancel each other. So we are getting tan inverse of 1 minus cos theta by sin theta. Now I am going to apply formula of 1 minus cos theta and sin theta. So tan inverse 1 minus cos theta formula is 2 sin square theta by 2, and sin theta formula is 2 sin theta by 2 cos theta by 2. That's why I told you need to recall all the trigonometric formula what we learned in the class 11. So 2 and 2 cancel. Sin theta by 2 cancel with sin square theta by 2. So sin theta by 2 cos theta by 2. So this will be equal to tan theta by 2. So this will be equal to tan inverse tan theta by 2. Tan inverse tan theta by 2 is equal to theta by 2. 1 by 2 and theta is equal to tan inverse x. So your answer is 1 by 2 tan inverse of x. Clear? So you need to identify the correct substitution. You can try by substituting x is equal to cot theta. Moving into the next problem. Tan inverse of cos x minus sin x by cos x plus sin x. Outside is tan inverse. So our target is somehow we need to simplify and write it in terms of tan of something, so that tan inverse tan theta is equal to theta. So first, tan inverse, divide numerator and denominator by cos theta. I am showing you the calculation here. So cos x minus sin x by cos x plus sin x by cos x. We are dividing numerator and denominator by cos theta. If we apply term by term division, so we'll get cos x by cos x is equal to 1 minus sin x by cos x is equal to tan x, divided by cos x by cos x is 1 plus sin x by cos x is equal to tan x. So here I am writing 1 minus tan x by 1 plus tan x. Clear? Next, tan inverse. In place of 1, we may write tan of pi by 4 minus tan x by 1 plus, this tan x can be written as 1 into tan x, that is 1 plus tan x can be written as 1 plus 1 into tan x. So in this 1 we may write tan pi by 4, so 1 plus tan pi by 4 into tan x. We arrange this term as tan pi by 4 minus tan x, 1 plus tan pi by 4 into tan x, to get the formula of tan of a minus b, that is pi by 4 minus x. That's why we are writing the term or rearranging the term so that we can apply the formula of tan of a minus b. If numerator contains plus, then we go for the formula of tan of a plus b. So this is equal to tan inverse tan of pi by 4 minus x. Tan inverse tan theta is equal to theta, so pi by 4 minus x. Let us solve this problem. Tan inverse 3a square x minus x cube divided by a cube minus 3a x square. Here, if you see, tan theta formula is 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. This is the formula of tan 3 theta. Now, you may ask why I am selecting this formula. Look at this term, tan inverse of this. So, if we just remove this term a, so 3 tan theta minus tan cube theta 1 minus 3 tan square theta. So we substitute here, so that means we need to somehow cancel a. So here we substitute x is equal to a tan theta. If a was not there, then we substitute x is equal to tan theta. Since a is there, so we substitute x is equal to a tan theta, keeping in mind that a from numerator and denominator will cancel. So from here we get tan theta is equal to x by a. It implies theta is equal to tan inverse of x by a. Each time I am finding theta because ultimately your answer should be in term of x by a or x. So we substitute tan inverse 3a square x. That means 3a square x, in place of x you substitute a tan theta. So you will get 3a cube tan theta minus a cube tan theta, a cube tan cube theta, because x is equal to a tan theta, therefore x cube is equal to a cube tan cube theta, by a cube minus 3 a cube tan square theta. Clear? In place of x, substitute x is equal to a tan theta. From numerator you can take x a cube common. From denominator you can take a cube common. Since a is greater than 0, so we can cancel a cube from numerator, a cube from denominator. So we get tan inverse 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. So this is the formula of tan 3 theta. So we will get tan inverse of tan 3 theta. So this is equal to 3 theta. Now replace the theta by tan inverse of x by a. So we will get 3 tan inverse of x by a. Clear? So again, before you practice or try to solve some problem, better recall, recap all those formula from class 11 trigonometry, so that you will not find any difficulty while solving the problem based on inverse trigonometric function. Now let us discuss this problem. Find the value of this expression. So we need to apply the concept we learned, how to find out the principal value. So sine inverse of 1 by 2. First we simplify this one and then we simplify the other part. So tan inverse 2 cos 2 sine inverse. Now this part is positive. So once I explain the principal value, this is positive. So your corresponding angle belongs to the first quadrant. First quadrant half means we can write sine of pi by 6. Sine 30 is equal to 1 by 2. So in place of 1 by 2, I am writing sine of pi by 6. So this is equal to tan inverse 2 cos 2 sine inverse sine theta. Sine inverse sine theta is equal to theta. So 2 into pi by 6. Now if you cancel 2 1 is 2, 2 3 is, so you get cos pi by 3. So tan inverse 2 cos pi by 3. Cos pi by 3 means cos 60. Cos 60 value is 1 by 2. This 2 and this 2 will get cancelled. So you write tan inverse of 1. Positive. So your corresponding angle lie in the first quadrant. First quadrant tan 45 is equal to 1. So we write tan inverse of tan pi by 4. Tan inverse tan theta is equal to theta. So your answer is pi by 4. Here the basic concept is we are applying repeated times application of principal value. Clear? Next, let us discuss this problem. Find the value of tan of 1 by 2 sin inverse 2x by 1 plus x square plus cos inverse of 1 minus y square by 1 plus y square. These all are conditions to define the function. So no need to worry about that conditions. So tan of 1 by 2 sin inverse of 2x by 1 plus x square. This is the formula of 2 tan inverse x. Cos inverse of 1 minus y square plus 1 plus y square. It is the formula of 2 tan inverse of y. Now we can take 2 common and we cancel out with this 1 by 2. So we'll get tan inverse of x plus tan inverse of y. Now here we are going to apply the formula of tan inverse x plus tan inverse y. So we'll get tan inverse x plus y by 1 minus xy. Tan into tan inverse theta is equal to theta. So we'll get x plus y by 1 minus xy. Clear? So again, formula is important to remember. Now let us discuss this problem. If sin inverse 1 by 5 plus cos inverse 1 x is equal to 1, we need to find out the value of x. So first we write the equation sin inverse 1 by 5 plus cos inverse of x is equal to 1. Now if I take this sine to the other side, so we'll get sin inverse of 1 by 5 plus cos inverse of x is equal to sin inverse of 1. This is positive. So here angle belongs to the first quadrant. So in place of 1 we can write sine of pi by 2, because sin 90 is equal to 1. So sine inverse sin theta is equal to theta. So we write sine inverse 1 by 5 plus cos inverse x is equal to pi by 2. Now we'll take this sine inverse 1 by 5 to the other side. So we'll get cos inverse of x is equal to pi by 2 minus sine inverse of 1 by 5. From here we can say that x is equal to cos inverse x is equal to this, therefore x is equal to cos of pi by 2 minus sine inverse of 1 by 5. Cos 90 minus theta. If I compare this with cos 90 minus theta, so result will be equal to sine theta, where theta is equal to sine inverse 1 by 5. So it implies x is equal to sine of theta. Theta means sine inverse of 1 by 5. Sine inverse, therefore x is equal to 1 by 5. Clear? Now find the value of cos inverse cos pi by 7 pi by 6. Can we directly apply cos inverse cos theta is equal to theta? So can we say cos inverse cos 7 pi by 6 is equal to 7 pi by 6? No. We need to keep range of cos inverse function is in our mind. Cos inverse x range is minus pi by 2 to pi by 2 in closed interval. So you cannot write cos inverse cos 7 pi by 6 is equal to 7 pi by 6. So that means you need to simplify this one. So cos inverse cos 7 pi by 6 we can write it as pi plus pi by 6. Clear? 6 pi plus pi 7 pi by 6. It implies cos inverse cos. Now cos 180 plus pi by 6. Now 180 plus pi by 6. So it will belongs to the third quadrant. It will belongs to the third quadrant. Cos 2 into 90. So cos remains cos pi by 6. Clear? And since it belongs to the third quadrant, it will be minus. So it will be minus pi by 6. So now let us discuss this problem. Cos inverse of cos 7 pi by 6. Can we apply cos inverse cos theta is equal to theta? Can we directly write this is equal to 7 pi by 6? No. Why I am telling you can't write this is not equal to 7 pi by 6? Because range of inverse is minus pi by 2 to pi by 2. Minus pi by 2 to pi by 2. So we write this as cos inverse cos pi plus pi by 6. Cos pi plus pi by 6. So cos 180 plus theta. So cos 180 plus theta, that means it goes to the third quadrant. Third quadrant cos negative. So we will get cos inverse of minus cos pi by 6. Still we can't apply this one. We can't apply this one because cos inverse cos theta is theta. Cos inverse minus cos theta, we don't know the formula. So what we need to write? Cos inverse, we write pi by 6 minus cos pi by 6 as pi minus pi by 6. Pi minus pi by 6. So cos remains cos minus pi by 6. So cos inverse cos, now it satisfies the range. So cos inverse cos is equal to theta. So pi minus pi by 6. So this is equal to 5 pi by 6. So I hope you understand the topic. Now first you need to go through the NCERT and then you follow the whatever reference book you are following. Try to solve the problem, the kind of problem given in the NCERT. So it will be beneficial across all board since syllabus is almost same. So follow the pattern of NCERT. Now for the competitive examination, next episode or the next part of this inverse trigonometric function is going to be very excited. I am come with some awesome tricks, way to calculate, how to find out the answer in second. We'll discuss in the next part. Till then, practice as many sum you can, because you need a clear concept to solve the problem of any entrance examination. Till then, goodbye.